Welcome back to another episode of How It Works. My name is Ken Baker from Green Pro Solutions, and today we are talking about pumps. In particular, we're talking about a Udor Delta 75. In this particular unit, they're using this pump. It's a 550 psi and a 21 gallons a minute. Now, what dictates that is you have an engine with so many horsepower and then your pump. Probably more information you need to know, but how we decide what pump you may need is the gallons that you may need. And depending on that, we'll tell you what size engine. And this happens to be a Vanguard engine, 14 horsepower. And the ratio comes out to 6:1. So that's what enables us to have the proper flow of your pump to give you what you need at the end. Now this particular pump, like most others like this, they have a suction, which is right here, that come off, and then there's the high pressure side that comes off. Other components here, this is your oil reservoir. This will go up and down when your engine is running. When it stops, it should be at the minimum. When it's running, it goes down and comes up a little bit. So that needs to be maintained, which we'll talk about in a few minutes. This here is what they call a head cylinder pump. Four, I mean, 1, 2, 3, 4. And this gets serviced once a year, which we'll go into a little bit here in a moment. This is a gearbox, which is between the pump and the motor. This gives you that 6:1 ratio, so the pump works efficiently. The motor runs faster, turns faster. This gearbox actually slows it down and does that 6:1 ratio. If a pump goes too fast, such as revving it very high, your RPMs, it doesn't work efficiently. So it's always important to look at the manufacturer's requirements for RPMs in the throttle on your engine. This gearbox here needs to be maintained. Also, you put your oil in the front. And on the side here, you fill the oil up. You take that screw out here, and you wait till it fills up and starts running out, and you know it's full. Now, some of the characteristics of this pump is that when you're using it with your manifold, and that's another one of the episodes for how it works, the pump has to suck something into it from one of the tanks that you're choosing, and it has to be relieved. So on your manifold, you have to have your return open. And this has happened before where they turn the pump on. It's sucking product from the pump and it has nowhere to go. If you have your return closed, you have a severe chance of damaging your pump to the point it may need to be rebuilt. Now there are safety features that are built in, but they're not meant to be held for any period of time. So when you're running a pump, just think about the fluids coming in and needs to have some place to go. So you always need to have your suction open and a return. In the video with the manifold system, I show you how to take from one tank and send it to another. But as long as the fluid has some place to go. Now what it does have as a feature, a safety feature, is on the filter. There's what they call a vacuum breaker, and it's a brass cylinder that's on your filter. And what that does is, if for some reason your filter is clogged and it can't suck product, it will open up and suck air. It favors water. It's designed for water, but it will pump air. It's better than pumping nothing. So no, I'm not contradicting myself when I say the return has to be open. The return still has to be open, but the vacuum also has to suck air in as well. Some of the other features with this that you need to maintain is that Udor recommends every year or every 500 hours this pump needs to be serviced, which these heads that I pointed out earlier need to come off, and the diaphragm and valves get replaced underneath here. If you do it once or twice, you get the hang of it, and it's quite easy actually. There are special things that you need to maintain to the manufacturer, such as torque specs when you're tightening the bolts and things of that nature. These clamps here is like a maintenance issue. We need to make sure these are tweaked every so often because they may come loose, expand and contract. And then that's another variable of troubleshooting, is that sometime between heat and temperature, vibration, cavitation, these clamps here may come a little loose, and you may be sucking air and you get a lot of vibration, which is called cavitation. And a good thing is to check the line from the suction all the way back to the manifold to make sure these clamps are tweaked with your wrench. So I think this is it for this particular pump. I thank you for joining us for another episode of How It Works.